Hey everybody, so today we're going to start trig equations. So solving equations that have trig functions in them. And in particular, we're going to be talking about trig functions that have period 2 pi. Okay, we'll deal with next time trig functions that have other periods because we have to be a little bit more careful with those. So again, today our goal, what I want you guys to get out of this video is a process for solving equations with trig functions. And you're going to see that as we solve these, this should reflect how we would solve a log equation, an exponential equation, sometimes quadratic. But a lot of those ideas that we used in those subjects are going to come back into play in this as well. So what I recommend, make sure you have your unit circles out. I've added the unit circle to this video as well. One change I want to highlight, now that we know what sine and cosine are, I replaced the x's and the y's by their corresponding parts. So instead of y, I put sine. Instead of x, I put cosine. Okay, so make sure you update your unit circles if you haven't already and make those changes. All right, let's get into it. All right, so we're going to do a couple of examples today. I have a procedure over here on the right, which I'll reveal as we do them. But what we're going to be doing is solving for theta in 0 to 2 pi. Now, this is telling us that whatever answers we come up with, they should be on the standard unit circle. Okay, one revolution around the unit circle. We don't want anything outside of that. Okay, so when you're solving a trig equation, what I recommend first, okay, pay attention to where theta is at. Okay, so in this case, again, as we noted, theta should be in 0 to 2 pi. Second, look at your equation and figure out what trig function are you actually dealing with. Okay, so in this case, we're dealing with sine. So what does that mean for us? Well, when we look at our unit circles, what coordinate are we going to be looking for? We're going to be looking at the y coordinate. All right, now we actually start to do things. So what I recommend, algebraically isolate the trig function. Get that trig function by itself. And this is the same thing that you would do if you're dealing with a log equation or an exponential equation. Okay, so how do we isolate the trig function? Let's add 1 to both sides and divide both sides by 2. Okay, so we get sine of theta is equal to 1/2. Okay, now once you've isolated the trig function, please erase. Trying to erase the last step here. We use our unit circle. Okay, so remember that sine of theta is equal to 1/2. So what we're going to be looking for is when is the y coordinate 1/2. Okay, so I want you guys to look at the unit circle, take a second, and I want you to look for the angles, because remember, we're looking for theta, we're solving for theta. What angles will give us a y coordinate of 1/2? Okay, so notice here, what are the angles that give us a y coordinate of 1/2? We have pi over 6 here and 5 pi over 6. Okay, and if you look at the bottom half of the unit circle, you have negative 1/2 in some of your y coordinates, so we don't want those. So our answers are going to be theta equal to pi over 6, 5 pi over 6. Okay. So this procedure that I've developed here for you guys on the right, this will work for all your trigonometric equations. However, step 3, that could be more challenging in some cases, which we'll explore a little bit today. All right, here's our next example. So we want to solve, again, we're keeping theta in 0 to 2 pi. We want to solve for cosine squared theta minus 3 is equal to 0. Okay, so notice, again, following the procedure, theta is still in 0 to 2 pi, so we're looking at our standard unit circle. We're dealing with cosine, so that means we're going to be looking for x coordinates. Okay, and then now next, we're going to isolate the trig function. So let's add 3 to both sides. Divide by 4. Okay, and then now, if we want to isolate the trig function, we're going to take the square root of both sides. Now be careful, and I see students do this a lot, remember when you take the square root in an equation, you have to add a plus or minus. Otherwise, you're going to lose some answers. Okay, so this simplifies to cosine of theta is equal to plus or minus. Now let's simplify this. So we have square root of 3 on the top. Now what's the square root of 4? That's 2. Okay, so we have two equations here. We have cosine of theta is plus square root 3 over 2, and cosine of theta is minus square root 3 over 2. Okay, so we want to look for, on the unit circle, what angles will give us square root 3 over 2 and minus square root 3 over 2 in the x coordinate, because we're dealing with cosine. So let me erase what we just did. Okay, and I'll give you guys a couple of seconds. Go ahead and look. When is the x coordinate square root 3 over 2 and negative square root 3 over 2? Okay, so notice what angles are we getting this time? So we're getting pi over 6, 5 pi over 6, because notice we have a negative square root 3 over 2, 7 pi over 6, and 11 pi over 6. So theta is equal to pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Boom. Okay, so keep in mind, when you have that squared there, like we had cosine squared here, and you take the square root, remember, add that plus or minus like we saw when we were doing the root method for quadratic equations. All right, our last example for today, slightly more complex than what we've seen so far. We have 2 sine squared theta plus sine of theta minus 1 is equal to 0. Okay, so notice we have 2 trig functions in this equation, where in the other ones we only had 1. Okay, we either had a cosine or a sine. So that's going to increase the difficulty a little bit. Now, how do we deal with things like this? Okay, what we're going to do is we're going to pretend, notice this looks like a quadratic equation, right? Here, I'm going to do this in green. It looks like this equation here. Okay, except instead of x, we have sine of theta. So solving quadratic equations, how would we solve this? We would factor this, right? What does this factor into? This factors into 2x, let's see, minus 1 times x plus 1. Let's take a second. Let's make sure that that's good. Let's see, 2x squared. This would be plus 2x minus x, so that's plus x, that's good. And then minus 1, yeah, we're good. Okay. And then this would tell us that 2x minus 1 is equal to 0. X plus 1 is equal to 0. Solve for x, we get x is equal to 1/2, and x is equal to minus 1. Okay. Now, another way you could have done that, if you're like, oh, I couldn't factor that, remember, you can always use the quadratic formula, and you would get these same 2 answers here. Okay. But remember, if you can factor, that usually will save you time. Now, we weren't solving in this question 2x squared plus x minus 1. We were solving 2 sine squared theta plus sine of theta minus 1 is equal to 0. So now all we have to do is apply what we did here, okay, to our equation up above. And notice when we solved the equation with x's, we got x was equal to 1/2, x is equal to minus 1. So all we have to do is substitute, instead of x, what do we really want? We want sine of theta instead. So this is called the substitution method that I stealthily, I should say, did here, okay? So here what I did from this step to this step, I let x equal sine of theta. And then from this step to this step, we're resubstituting x for sine of theta. Okay, this is something that you'll see in calculus at some point. Okay. In any case, if your equation looks like a quadratic equation, substitute your trig function for x, solve the equation like you would normally, and then at the end, resubstitute. Okay. Now we're not done, we're almost done, but now we have two equations here. Sine of theta is equal to 1/2, sine of theta is equal to -1. Okay, so we look at our unit circle. When is the y coordinate 1/2? When is the y coordinate -1? So again, I'll give you some time. When is the y coordinate 1/2? And when is it -1? And let me erase what we did before. Okay, so when is the y coordinate 1/2? Notice we have pi over 6 again. 5 pi over 6. And that's going to be when the y coordinates are 1/2. Now, when is the y coordinate -1? That only happens here at 3 pi over 2. So we have pi over 6, 5 pi over 6, and 3 pi over 2. Theta is equal to pi over 6, 5 pi over 6, and 3 pi over 2. Okay, so again, just to summarize, how do you solve trigonometric equations? I recommend this procedure. First, pay attention to where is theta, okay? What can theta be? Okay, that'll tell you what unit circle to look at. Okay, in this case, 0 to 2 pi, that means we're looking at just the standard unit circle. 2, what trig function are you looking at in the equation? Okay, so are you dealing with sines? Are you dealing with cosines? Are you dealing with tangents? That's going to tell you what to do with your coordinates when you look at your unit circle. Step 3, and I'm going to put a little star next to this, algebraically isolate the trig function, so get the trig function by itself. Okay, and then finally use the unit circle, combining steps 1 and 2 to figure out what does theta have to be to get you whatever your equation is telling you to get.